Okay, so today we are going to talk about always the matter, but the last class we were talking about boiling, boiling. Yeah, we were talking about boiling. Okay, so let's see. You have ready your notebook there. Okay, today we are going to talk about evaporation. Evaporation. What's evaporation? Where can you see evaporation?
In
In the kitchen.
the kitchen when you are
Mhm.
In volcano.
how do you say calentando agua, mister?
Mhm.
And there is evaporating all the water. It's like smoke.
Yeah, would be the same evaporation and boiling would be the same.
No, no.
Sure.
Or maybe
What would be the difference between them?
boiling, that is that evaporation. You know that it uh, No, Mr. Is the same.
No,
No,
okay,
the same.
yes.
It's
What is it?
different.
Yeah, but what is the difference between them? What
That
do you think?
is that evaporation.
Can be evaporation with the drying.
That with the drying, yes. No, what? The evaporation with the drying, not. Or yeah, can be.
Can be right
Yeah. It can be.
because if there is a little pond there, for example, in the raining, you know that and the land makes a little pond in the holes. You know that that's water can evaporate. That's water that is in the land. That's little pond. Yeah, can evaporate. For example, another example of evaporation is when you are washing your clothes. Yeah. Well, who washed the clothes here? Only your mom or the machine or the machine, the laundry.
What, mister?
When you
Mister,
wash your
you
clothes,
are like
What, Mister?
you
Mister, you
you
are
hear
like a
He's
robot.
like a robot. No.
Mister.
ah
Mister.
las engañé. ¿Va? Okay. Okay. Let's see. When you, for example, when your mom is washing the clothes, okay, and she put the clothes there in the jar, and the sun is evaporating to dry the clothes, right? Another example, the pond, I told you, okay, the puddles, I told you. For example, another is well, mm, for example, when you iron, when you iron your uniform, but your uniform is wet. For example, when you iron your uniform, yeah,
Yeah. Yes,
yes,
it
or
there
yeah,
is
yeah, it's not
like an
no
smoke.
no not clear what I say, right? Okay, yes, okay. When you use your iron, for example, tomorrow, imagine that you forgot to clean or to wash your uniform, and you do it at night. So in the next morning, of course, your uniform is going to be wet. Yeah. Then the only thing to dry your uniform is using your iron. Yeah, your iron. Yeah, the iron is evaporating the wet of your clothes, right? The wet. Or there are people or there are students, and I did it when I was in high school, that I put my socks back in the backside of the refrigerator You know, you did it.
When my mom too, when her uniform is like wet, she
Mhm.
put it back of the refrigerator, and at the next morning it is.
Is the last
Yes,
option?
I
mister.
No,
know, mister.
Yes.
that
The
is
shoes
the
when it's
that
rain.
shoes. Yes, that is the last option you have if you want to have your uniform dry, right? Is the only one, the only option. And well, I when I was in high school, I did it. Yeah, I did it. But also my shoes. Okay, my shoes. Yeah, you have done right. That is why you are smiling. Okay, so let's see. I'm going to show you a video about evaporation. What's evaporation? Okay, so let's see. Everything have to be or is related with the matter. Okay, with the matter. So let's pay attention. Sorry.
Huh?
Eric is talking with her mom. Okay.
Did you have your microphone on?
All around us. It's what drives
Okay.
the water cycle, giving magnificent clouds the water they need to form. It's the reason you cool down when you sweat, and can even produce beautiful crystals. It is a truly important part of this world, and in this video I'll be explaining what evaporation is and why evaporation happens, and hopefully you'll be able to explain it too by the end of this video. I'd like to introduce evaporation in a way you might not have looked at it before, because we're all very familiar with the concept of a liquid turning to a gas. But why is evaporation any different from boiling, and how can it happen at a lower temperature than boiling? To start with, we need to review the kinetic model of matter, which states that solids are made up of particles fixed in position and vibrating, liquids made up of particles which are free to move but are still bound to each other, and gases being made up of particles free to move but with empty space between them. To explain evaporation, we first need to consider a liquid and what we mean by the temperature of it. Temperature can be thought of as the average energy of the particles in a substance. Put simply, the averages of the speeds of the particles. Liquids and gases with higher temperatures have their particles travelling at higher velocities, while liquids and gases with lower temperatures are made up of slower moving particles. But in order for evaporation to occur, we need to turn our attention to the word average in our definition. This implies that particles are not all travelling at one speed, but are in fact travelling at a huge range of different speeds and thus have different energies. Think of it like watching the start of a marathon. There are many different people setting off with many different speeds, but the average speed of all these people will give an average time of around 4.5 hours. Therefore, if a particle has enough speed and is heading towards the surface of a liquid, it may have enough energy to break free of the attraction between it and the rest of the particles, and so enter into the gaseous phase. This is what we mean by evaporation, and can occur at low temperatures due to the fact that there are many particles with lower energies than the high energy particles escaping from the liquid, thus giving a lower average temperature. This is the reason why water evaporates faster in a warmer environment. A higher proportion of particles have enough energy to escape, as the average energy of the particles has increased. If you keep on increasing the temperature, the particles do not even have to reach the surface in order to turn into gas, and so form bubbles in the liquid. You may recognise this from the kettle bubbling when it is finished, and for good reason. This is the point at which the liquid is boiling. If you apply these concepts to the surrounding world, you can see that evaporation plays an important role in many processes, including the sun heating the sea in order to give water vapour. You may have also noticed that puddles don't just sit there, and while they are not boiling, they do in fact decrease in volume over time, which is due to the water gradually evaporating out of the puddle.
So that is what I told you, or I asked you, right? Can this little puddle evaporate? Yes, of course. So that is depend the weather and the temperature of the sun, right? Of the day. Because imagine that if we have this puddle now in this moment with this weather that we have now, do you think that it can evaporate with the weather that we have now, right now? No, I don't think that it can evaporate with the weather that we have now. With the weather now, we can, because if we want to see the evaporation for this puddle, we need to have the sun and with all that temperature, you know, that temperature, very important. But the weather like that, I think not. I think not. So in some minutes, it's gonna start to rain again. Okay, but I like the raining day. I like the raining day. You can sleep delicious. Yeah. Okay. So let's see. So evaporation is different from boiling, right? From boiling. And the evaporation is part of the cycle, right? The cycle of the weather cycle. Yeah. So wait. Science, okay? The water cycle, okay? Because all that water that is in the land, on the puddles, is evaporating, and that vapor goes up to the atmosphere and create the clouds. Yeah, the water cycle. Okay, so let's see. Right down there, evaporation. What is evaporation? This is the topic. What is a question, but is the topic also. What is evaporation? Evaporation. Okay. What's evaporation? I never find a question mark. Um, Today we say is Monday.
Mister,
Yes.
in what is in preparation you put it and not is.
Okay. Monday, July 5th, 2021. Okay. What is evaporation? Okay, but also we have, well, the vocabulary, we have evaporation. Evaporation. Okay, but what we are going to say about evaporation and what is evaporation? Evaporation is the process whereby whereby liquid changes into gas when it occurs. Gas.
We rebuy.
Okay, it occurs.
Means you have we rebuy.
Yes, what is? Yes, it's like that.
Whereby.
Yes, together.
Whereby means
Yes. Okay. Um, it occurs. It occurs. Okay. Happen. Okay. It occurs when water gains heat.
What?
Gains heat. Okay. These causes the particles in the water. As the video you see the particles, the water to gain energy and vibrate faster, faster. Yeah,
Finish.
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 The
I
rest,
finished, mister.
I finish.
I finished,
okay.
mister.
Whereby means, this word means en la cual, okay, en la cual. Okay, finish everybody.
No. I finished, mister.
Okay.
Finish, mister.
When a liquid, the second information, when a liquid gains enough heat to change from the liquid state to gaseous, to the gaseous, sorry, gaseous state. In other words, we call it vapor. Okay, vapor. To have this kind of vapor, we need boiling. All right. For example, when we have a kettle with boiling, we can see the vapor, right? We can see the vapor. But when we have this process of evaporation, we cannot see the vapor, yeah? Or when you see the water cycle, you see the vapor? No, right? You cannot see the vapor without boiling. Okay. This is the comma. We say that the liquid has evaporated. Has evaporated.
Finish.
I'll finish.
Finish.
I finish, mister.
Finish, mister.
Me too, mister.
Okay, evaporation. The evaporation can take place in different time of or environment. For example, if you spray your body, for example, if you spray your body with a perfume, so automatically you are going to see the perfume there in your body, or it disappears. What do you think? What do you think?
It disappears.
It disappears, right? It disappears.
Yes.
Yeah, it disappears. Or for example, another sprays you use, right? Or when you sweat, yeah. When you sweat, sometimes the evaporation or the sudor disappears, right? Or for example, when your hand is wet and you put your hand in in a sheet of paper, so you are going to see wet, but 5-10 minutes it disappear. Yeah, it disappear. Also in the poodles, okay, in the poodles and all that are
Mister,
examples of evaporation. Yeah, Hasiel?
may I go to a bathroom, please?
Yeah, quickly. Okay, so now we are going to make a chart. Okay, I want you to make the chart there. Make the chart.
Mister, can I go to the bathroom?
Yes, quickly, quickly. Why I am working in this one. Okay. Okay, I have. Then we are going to make a chart. See me. See ya, Mister. Okay. Oh, this line is so is not straight line. It's not a straight line. Hey guys, so I have a question. There is one of you that do not understand something in math about the angles. No, no one. Okay. Okay, please. Now we're gonna see the difference
No,
between
mister.
evaporation and boiling. Okay. That is the air that is that Dennis cow. What is the name of the cow? Dennis? Lolita.
What, mister?
What is the name of your cow? Lolita or what?
There are Rosita,
Uh-huh.
Estrella, Gaviota, en, en Niño.
Really? And they
Yes,
understand when you
yes,
call the names? Really?
yes, yes.
Okay, boiling. Boiling. Okay, boiling. Okay, right there. Okay, take place all the time. Take place all the time. All the time. Take place all the time. This is for evaporation. Now for boiling. Take place at a fixed temperature parentheses we write at its boiling point. Boiling point. Boiling point. Okay. Then we are going to trace a line. remember to have your notebook in order, right? Occurs on the surface of the liquid. Yeah, like that. Liquid, yes, yeah. Liquid only. Okay. Occurs throughout sorry, the liquid. This is in boiling. Okay. You remember that video? How they make and how they do it, fast and slow, but which one? Evaporation is fast or boiling is fast or evaporation is slow? What do you think?
This is slow.
Boiling is slow.
And evaporation is faster.
What is faster, evaporation or boiling? Because you know, evaporation, I can have my, for example, my pants, okay, can be wet. If I put it out of the house, um, do you think that they are going to evaporate the water fast or slow?
Slow.
Slow. Then evaporation is slow. Yeah, is slow, very slow. Very slow. Yeah, very slow. And boiling, of course, because boiling is in the stuff. Yeah, is very fast.
So the two are very.
Very fast.
Finish.
Okay. Finish.
That is Mr.
Yeah.
That's
The rest of the class.
Finish, mister.
Finish. Very good.
I finish, mister.
Finish, Mr. Bye. See you in math.
Bye.
Why'd you say bye?
finished, mister.
I have to be sure that all of you finish.
Me no, Mr. Wait me. The last one. No, why? Very slow and very fast.
Look, Mr. I finished.
Me too, Mr.
Okay, so yeah, the students already finished. Can disconnect and wait.
And I, mister. I finished.
Can disconnect and wait in math.
I Mr.
Yes, mister. Bye.
Me no, I will wait. You too, Mr. I will go to the platform of mathematics.
Bye, mister. I finished.
Okay, everybody finish?
Teacher, I don't connect in the first class because I don't have internet.
Yes, yes. Mr. Marion told me.
Ah, okay.
Yes, don't worry. Okay, everybody finish?
Yes.
Sure. Areli, Natalie, Eunice.
I finished,
Peanuts
mister.
are
Bye,
missing.
mister.
Peanuts are missing.
Bye,
Okay,
mister.
the students that already finished can disconnect and wait in math.
I finished, mister. I finished, mister.
Okay.
Goodbye.
Goodbye, Mr.
Okay, everybody finish?
Yes.
Okay, I see you in math then.